Hey, what's up, guys? Yeah, so today I want to talk about this some of so-called the law of total expectation and the law of total total variation, law of total covariance, and all these are based on the same proof technique. And yeah, I will collect them and make 3 videos, and I hope you guys subscribe to my channel. By the way, I feel this is very interesting plot. Okay, see you. Yeah. Okay, so hope you guys subscribe to my channel. Okay, so this is a famous law called the law of total expectation value. Also, just for convenience that I don't want to talk about major theory in this video, so I would assume that this x, y are random variable and that they're all finite. Okay, so basically they have only finite value, so x only have finite value to choose, and y only also have finite value to choose. And the expectation of x, expectation of x, expectation of expectation x, condition on y. So this is the theorem. Okay, so before we do this, we should talk about notation. Okay, so this is very important because I think in the probability theory that or in the usual mathematics that people don't understand notation. So if you don't understand notation, that you are not that everything looks like bizarre to you. Okay, so we start with to notation so that everything can be done clearly. Okay, so for this one that things are finite, right? So I can say that basically there you have joint probability distribution P, such that you can talk about x equals to small x and capital Y equals to small y. So these are some number, and your joint probability distribution will make these to be 1, and all these are positive, not negative. Okay, and expectation of x is defined to be just x, right? So we just take the P of x equals to x. And what? And y equals to y, right? And the sum of x, y, but only takes x. Okay, right? So this is the definition. Right, so expectation x is number, right? Okay. So how about expectation value of x conditional on y? Okay, so this is very important. When one say x conditional on y, what it means is that this guy's expectation on x, but conditional on y. Okay, so you should imagine that I write this as the following. I write there's a y equals to small y. Okay, so this means that I give the definition so that I get the probability p, right? And the x. And I need to sum of x, right? So I come x and the y equals to y and the x. Okay. And the sum of x. Okay. So this is the definition. Okay, so this means that when I condition on y, that I just condition on y probability x. Okay, so this is definition. This is definition. Okay, so this guy is not a right. If you fix y, then it becomes a number, right? If you fix y, right? If you don't fix y, then this guy is a random variable, and the random variable is take out from y. Okay, so you pick y, and you can evaluate the expression. Okay, so now this expression should be understood as expectation of x, and over right this equals exponential xy. So this expectation, sorry, not exponential, it's expectation. Expectation of x is the same as expectation of x condition on y. So this guy right is a random variable. Y, right? Y. Okay. So it means there's a here, it should be y. Okay, very important. You should understand this notation, otherwise that everything looks bizarre to you. Okay, so now we have everything, then we can go to a proof. Okay, so write down the definition. E of x is xy, probability of x equal to small x, y equals to small y, x. Okay. And x here, small x. Okay. What's the expression of xy? Let me just write again. By definition, it's a definition. So it's probability of x equals to x. Yeah, let me just pick it to be y, just for convenience. And y equals to y condition. And x, right? And the sum over x. Okay. Now I want to take the expectation value of the again, right? Take on there's a y here. Okay, so this means what? Y, right? So what should I do? I should times the probability of y equals to y, right? Because this guy, right, is an expression of y. Okay, so I should take over this and the sum over y, right? This is definition. Okay. Okay, so now I can write as a xy probability of x equal to small x, y equals to y, and the probability of y equals to y and x. Okay, and this is condition probability. This guy's probability of x equals x, a condition on y, right? So this is the by definition of condition probability. Y equals to y, x, summation of x, y. So they are the same. Okay, so you can see this kind of prove just definition, right? So the only mysterious part is this part, is this part, right? So okay, so when you do the expression on y, then you should sum over y and then take a probability of y equals to y and then take everything. Okay, so because now you already condition on y, so this part you already condition on y, right? So you don't care about x and take expectation y. Okay, and so basically these are everything. Okay, so in the next video that we will prove that the total this total expectation total law this a law of total variance. There's another theorem that that we can talk about. See you guys next videos.